exercise 1.1 from the chapter differentiation. In the third example, x square plus 4x plus 1 bracket raised to 3 plus x cube minus 5x minus 2 bracket raised to 4. We have to find the derivative of this function. So let y is equal to the given expression x square plus 4x plus 1 bracket raised to 3 plus x cube minus 5x minus 2 bracket raised to 4. Now we have to differentiate this with respect to x. So after differentiating, derivative of y is dy by dx. Then here there is addition of two functions. So we have to take the derivatives of their addition. So derivative of the first x square plus 4x plus 1 bracket raised to 3 plus d by dx of the second x cube minus 5x minus 2 bracket raised to 4. Now the derivative of the first expression x square plus 4x plus 1 bracket raised to 3 is obtained by using the chain rule. Treat this bracket function as f of x as x square plus 4x plus 1. So here we get f of x raised to 3. Its derivative is given as 3 times f of x raised to 3 minus 2, 3 minus 1, it is 2 into d by dx of f of x. On the same line, here also we will treat this x cube minus 5x minus 2 as f of x. So f of x raised to 4 and its derivative is 4 times f of x raised to 4 minus 1, it's 3 into f dash of x. F dash of x means d by dx of x cube minus 5x minus 2. So on the second line, we will find the derivatives of these brackets. So what is the derivative of x square? Its derivative is 2x. Derivative of 4x is 4 into 1 and derivative of 1 is 0. So here the derivative of x square plus 4x is 2x plus 4. Similarly, derivative of x cube minus 5x minus 2 is 3x square minus 5. So what is the answer? Dy by dx is equal to this 3 into, we can take 2 common from this term. So 3 into 2 is 6, but remains x plus 2, this factor, and then x square plus 4x plus 1 bracket square plus this 4 into this factor 3x square minus 5 into x cube minus 5x minus 2 bracket raised to 3. This is the derivative of the given function. Now the second one, x plus 4x bracket raised to 5 into 3 plus x minus x square bracket raised to 8. Again, let y is equal to the given function. Then we have to differentiate this with respect to x. Now look at this function. Now here there is a product of two functions, product of two polynomials. One is 1 plus 4x raised to 5 and other is 3 plus x minus x square bracket raised to 8. So here we have to use the product rule that you have already learned in the 11th standard. What is the product rule? D by dx of u into v is keep first function u as it is into derivative of the second function plus keep second function as it is into derivative of the first function. So here 1 plus 4x raised to 5 will keep as it is into d by dx of the second function plus then second function will be as it is into d by dx of the first function. So using that product rule, the d by dx of 3 plus x minus x square raised to 8 is f of x bracket raised to 8. Its derivative is 8 times f of x raised to 8 minus 1 is 7 into f dash of x. So 3 plus 8 times 3 plus x minus x square bracket raised to 7 into d by dx of 3 plus x minus x square. And here the derivative of 1 plus 4x raised to 5 is f of x raised to 5, its derivative is 5 times 1 plus 4x raised to 5 minus 1, that is 4, into f dash of x, that is d by dx of 1 plus 4x. So in next step, what is the derivative of 3? Derivative of 3 is 0. Derivative of x is 1. Derivative of x square is 2x. And derivative of 1 is 0. Derivative of 4x is 4. Simplify it. 8 in bracket 1 plus 4x raised to 5 into 3 plus x minus x square raised to 7 into 1 minus 2x plus 5 into 3 plus x minus x square bracket raised to 8 into 1 plus 4x raised to 4 into this 4. Now take this 4 and this 5, take their multiplication, we will get 20. So now here, what are the common terms? They have taken the common terms common. So here 1 plus 4x raised to 5. Here 1 plus 4x raised to 4. So what term we can take outside? 1 plus 4x raised to 4. Here 3 plus x minus x square raised to 7. And here 3 plus x minus x square raised to 8. So from these two we can take outside 3 plus x minus x square bracket raised to 7. Again here there is 8 and here there is 5 and 4. So we can take 4 outside. So 4. So what remains? 4 in 4 to the 8. So 2 is remaining in first term and 1 minus 2x is also remaining. Again 1 plus 4x is also remaining. In second term, 4 we have taken common. 1 plus 4x raised to 4 is also taken common. And 5 will remain and 3 plus x minus x square. This term is also remain there. Simplify these two terms. Multiply 1 plus 4x and 1 minus 2x and simplify it. 2 plus 4x minus 16x square plus 15 plus 5x minus 5x square. Add and subtract the terms. You get dy by dx is equal to 4 in bracket 1 plus 4x raised to 4 into 3 plus x minus x square bracket raised to 7 into 17 plus 9x minus 21 x square. Now the next example is differentiate the following with respect to x. X upon square root of 7 minus 3x. So let y is equal to x upon root 7 minus 3x. Now here, how to differentiate it? Here there is a quotient of two functions. That means division of two functions, numerator and denominator. So we have to use here quotient rule. Now what is meant by a quotient rule? That you have learned in the 11th standard. Y is equal to u upon v. How to find the derivative of u upon v? So in denominator v square, then in numerator v into du by dx minus u into dv by dx. So this is the quotient rule. Use that quotient rule. The derivative of x is 1 and derivative of root 7 minus 3x. Now root of 7 minus 3x is nothing but root f of x. Its derivative is 1 upon 2 root f of x into f dash of x. So what you get? 1 upon 2 root 7 minus 3x into d by dx of 7 minus 3x. And in denominator, square of root 7 minus 3x. So root is cancel and you get 7 minus 3x. So simplify again, you get the derivative of 7 is 0 and derivative of minus 3x is minus 3. Then root 7 minus 3x plus 3x upon 2 root 7 minus 3x divided by 7 minus 3x. Simplify, take the 1 upon 7 minus 3x common and here take the LCM of in this numerator, multiply divided by 2, multiply divided by 2 root 7 minus 3x. So you get this 1 upon 7 minus 3x into 14 minus 3x divided by 2 in root 7 minus 3x, that is 14 minus 3x upon 2 times this 7 minus 3x raised to 1 and root 7 minus 3x means 7 minus 3x raised to half. So 7 minus 3x raised to 1 plus 1 upon 2, that is 3 by 2. The next example is x cube minus 5 bracket raised to 5 upon x cube plus 3 bracket raised to 3. Again, you have to use the quotient rule. Differentiate with respect to x. What the quotient rule tells us that we have to take the square of the denominator. then numerator, denominator is as it is into derivative of the numerator minus numerator as it is into derivative of the denominator. So x cube plus 3 bracket raised to 3 as it is. Now the derivative of x cube minus 5 raised to 5 is 5 times x cube minus 5 bracket raised to 4 into 3x square minus 0. So what is 3x square? Is the derivative of x cube minus 5. Similarly, the d by dx of x cube plus 3 bracket raised to 3, its derivative is 3 times x cube plus 3 bracket raised to 2 into d by dx of x cube plus 3. So d by dx of x cube plus 3 is 3x square plus 0. So now this 5 into 3 is 15x square, and here this 3 and this 3 is 3 into 3 9x square. The remaining terms are as it is. Now what terms we can take outside? Now here we can take a 3x square from the first term and 3x square from the second term. Then here x cube plus 3 bracket raised to 3, and here x cube plus 3 bracket raised to 2. So we can take bracket square outside, and x cube minus 5 bracket raised to 4 and x cube minus 5 bracket raised to 5. So from these two terms, x cube minus 5 bracket raised to 4 we can take outside. So what remains? So 5 times x cube plus 3 minus 3 times x cube minus 5. These terms are remaining. So simplify these terms, multiply them and simplify. You get 5x cube plus 15 minus 3x cube plus 15. So minus 3x cube plus 3x cube will get cancelled to each other, and 15 plus 15 you get 30. So 5x cube minus 3x cube is 2x cube. They will not cancel to each other. Their addition is 2x cube. 2x cube plus 30. Then we can take this 2 common. So it becomes 6x square into x cube minus 5 bracket raised to 4 into x cube plus 15 upon x cube plus 3 bracket raised to 4. Next example. Differentiate the following with respect to x. 1 plus sine square x bracket square into 1 plus cos square x bracket cube. So given y is equal to 1 plus sine square x bracket square into 1 plus cos square x bracket cube. Differentiate with respect to x, we get, again here there is a product of two functions, so we have to use the product rule. We will keep first function as it is into derivative of the second function plus the second function as it is into derivative of the first function. So first function as it is, d by dx of the second is f of x, its cube is 3 times f of x square into f dash of x. So d by dx of 1 plus cos square x. Similarly, d by dx of 1 plus sine square x bracket square is f of x square. Its derivative is 2 times f of x into f dash of x. So f dash of x means d by dx of 1 plus sine square x. So d by dx of 1 plus cos square x is 0. D by dx of 1 is 0, and d by dx of cos square x is 2 cos x into minus sin x. So it becomes minus 2 sin x cos x. Similarly, sin square x, its derivative is 2 times sin x into cos x. So dy by dx is equal to minus 3 times 1 plus sin square x bracket square 1 plus cos square x bracket square into sin 2x, because 2 sin x into cos x is sin 2x, and plus 2 times 1 plus cos square x brackets cube into 1 plus sin square x into sin 2x. So dy by dx is equal to 1 plus sin square x into 1 plus cos square x bracket square into sin 2x. These three terms we can take common from these two terms. So what is remaining? Minus 3 into 1 plus sine square x plus 2 into 1 plus cos square x. These two terms are remaining. Multiply by minus 3 this 1 plus sine square x and 2 by this 1 plus cos square x. Then you get this term. Rewrite it. You get 2 cos square x minus 3 sine square x minus 1 into this, the first common taken part. So this is the derivative of the given function, given expression. Differentiate the following with respect to x. Root cos x plus root cos of root x. Again, let y is equal to the given expression. Then differentiating with respect to x, here there is addition of two functions. So dy dx of the first function plus dy dx of the second function. So dy dx of the first function, root f cos x means root f of x, and derivative of root of f of x is 1 upon 2 root f of x into f dash of x. So dy dx of cos x. Here is also root f of x means 1 upon 2 root f of x into f dash of x, dy dx of cos of root x. Now here dy dx of cos x is minus sin x, and dy dx of cos f of x is minus sin f of x into f dash of x, minus sin f of x into dy dx of f of x. That is root of dy dx of root x is 1 upon 2 root x. So how we can simplify it? This simplify this minus sin x upon 2 root cos x will as it is, and minus sin root x upon these 2 and these 2, it becomes 4. Then root cos root x and root x, I will combine it and write it in the same radical sign. So I get root of x cos root x. Now the next one, third was from the third type. The example is seventh example, log of sec 3x plus tan 3x. Let y is equal to log of sec 3x plus tan 3x. So differentiating with respect to x, this is of the form log of f of x. Now what is the derivative of log of f of x? Is 1 upon f of x into f dash of x. So 1 upon f of x into f dash means d by dx of sec 3x plus tan 3x. Now there is addition of two functions. So the d by dx of the first function plus d by dx of the second function. So what is the derivative of sec 3x? Its derivative is sec 3x into tan 3x into d by dx of 3x, because I am using the formula sec of f of x. D by dx of sec f of x is sec f of x into tan f of x into f dash of x. F dash of x means this d by dx of this 3x. Similarly, d by dx of tan 3x, what is the derivative of tan? It is sec square. So sec square 3x into f dash of x means d by dx of 3x. Now here d by dx of 3x is 3, because 3 is constant, we can take outside the derivative, and x derivative of x is 1. So we get 3. Now from this term, what we can take outside? We can take 3 common and sec 3x common. 3 and sec 3x, both of them we can take the outside. And what is remaining in the bracket? Sec 3x plus tan 3x, which is the same as the denominator. So these two terms will cancel each other. And what we get? Dy by dx is equal to 3 sec 3x is the derivative of the given function. Next example is differentiate the following with respect to x. 1 plus sine x raised to 0. X raised to 0 means x degree. 1 plus sine x degree upon 1 minus sine x degree. Let y is equal to 1 plus sine x degree upon 1 minus sine x degree. So initially I will convert this into the radian. So x degree is equal to pi x upon 180 radian. So multiplied by it, 1 plus sine pi x upon 180, 1 minus sine pi x upon 180. Now we will differentiate it. Now here there is a quotient u upon v. They will divide there is a division of two functions. So what we can do? We have to use the quotient rule. How to use? Take the square of the denominator, 1 minus sine pi x upon 180 bracket square, then keep the denominator as it is into d by dx of the numerator, minus numerator as it is into d by dx of the denominator. Now derivative of 1 is 0 and derivative of sine of f of x. Derivative of sine f of x is cos f of x into f dash of x. Similarly here also derivative of 1 is 0 and derivative of minus sine pi x upon 180 is derivative of sine f of x is cos f of x into f dash of x. F dash of x means d by dx of pi x upon 180. So the derivative of pi x upon 180 is pi upon 180. So from these two terms, what we can take outside? We here cos pi x upon 180. Here is also cos pi x upon 180. Here is also pi upon 180. Here is also pi upon 180. So these two terms we can take outside, and the remaining terms we'll write in the bracket. 1 minus sine x. Now again I am converting it in the radians into the degrees. Sine pi x upon 180 is x degree. Pi x upon 180 is x degree. Pi x upon 180 is x degree. So what are the terms which take outside? Pi upon 180 into cos of x degree. And what will remain? 1 minus sine x degree plus 1 plus sine x degree. So plus sine x degree and minus sine x degree. These two terms will cancel. 1 plus 1 is 2. That 2 will divide to this 180 and you get pi upon 90. So pi upon 90 into cos of x degree upon 1 minus sine x degree bracket square is the derivative of the given function. Now the next one, differentiate the following with respect to x. Cot of log x by 2 minus log of cot x by 2. Let y is equal to this. Then differentiating with respect to x. Here again I use the derivative of the composite function. That means chain rule. Here d by dx of the first function minus d by dx of the second function. Now here there is a composite function cot of f of x. Its derivative is given by minus cosec square f of x into f dash of x. Similarly here log of f of x, its derivative is 1 upon f of x into f dash of x. After using that formula, the d by dx of log x upon 2. Now here 1 upon 2 is constant, so we can take outside. And what will remain? Log x, its derivative is 1 upon x. Similarly, here is also 1 upon 2 we can take outside, and the remaining term cot x, its derivative is minus cosec square x. Now simplify it. This 1 upon 2x can be written initially. So minus 1 upon 2x cosec square log of x upon 2 minus minus become plus. This tan x can be written as sin x upon cos x, and this cosec square also can be written as 1 upon sin square x. So one sin is cancelled here. Minus 1 upon 2x cosec square log of x upon 2 plus 2 upon 2 sin x cos x. But sin 2 sin theta cos theta is nothing but sin 2 theta. So put this value here, you get the required derivative of the given function. Now differentiate the following with respect to x. E raised to 2x minus e raised to minus 2x upon e raised to 2x plus e raised to minus 2x. Let y is equal to this function. Then we have to differentiate it with respect to x. Again I use the quotient rule. Square of the denominator, then denominator as it is, derivative of the numerator, minus numerator as it is, derivative of the denominator. Now e raised to 2x, derivative of e raised to 2x is 2 e raised to 2x. Derivative of e raised to minus 2x is minus 2 e raised to minus 2x. So use that formula. Here 2 e raised to 2 we can take outside. Here is also 2 we can take outside. Then e raised to 2x plus e raised to minus 2x. Both the terms are present here. So we can take outside then minus 2 e raised to 2x minus 2 e raised to minus 2x whole bracket square. So if I take the 2 common, then I will get a square minus b square. So what is the expansion of a square minus b square? Is a minus b, a plus b. After using that, the terms will cancel to each other and you get 2 times 2 e raised to 2x into 2 e raised to minus 2x. After multiplying 2 2s are 4, 4 2s are 8, and e raised to 2x into e raised to minus 2x is e raised to 0, but anything raised to 0 is 1. So I get 8 upon e raised to 2x plus e raised to minus 2x bracket square.